I'll help you score full marks in MCQs. So these are the 6 MCQs. Let's read the first one. The product of a rational and an irrational number is always irrational, always rational, rational, or irrational, or will have the value 1. So as we know, the rational number can have 0 or non-zero value. So if you see the explanation, if the rational number is 0 and you multiply with irrational, answer will always be 0, and 0 is what? Rational number. And if the irrational number is non-zero, that you multiply with irrational number, so your product will be irrational. So that means it can have either rational or irrational. So a correct answer will be C option. Now let's read the second one. If one zero of this polynomial is the negative of the other, then it will have the polynomial will have no linear term, constant term is negative, or has no linear term, constant term is positive, or these two other options. So let's see. Just don't read this as A, just read this as an alpha, because A is already there. So the zeros be alpha and minus alpha. Let's assume that. Then the sum of the zeros, simply if you add it up, then it will come to be 0. And likewise, you find the product A into minus A. Whatever the value of alpha will be, that it will always be negative, that we know, right? So that means product gives you constant, which will always be negative. And this sum gives you what? It gives you the linear term, because polynomial, as you know, x square minus sum of the zeros into x and plus product of the zeros. So since sum of the zero is 0, so it will have no linear term. It will not have x term. So the correct option will be it has no linear term and the constant term is negative. Now see this, the third one. The pair of equation x is equal to a, y is equal to b, if represented graphically, then representing lines which are this intersect at 1. Will they be parallel, intersect at BA, coincident, or intersect at A and B? So of course this figure will not be given to you. This is just to explain you, right? So x is equal to a what? X is equal to a means y is equal to 0. So it will be a parallel line, right? Parallel to the x-axis. And y is equal to b means x is equal to 0. So it will be a vertical line which is parallel to the y-axis. Horizontal line and the vertical line, they will meet at this point A and B. So the correct answer is intersecting at A and B. Now, okay, now fourth one. This might look difficult, but trust me, it's very easy. If P is this, AQ into B raised to the power 4, and Q is A square B raised to the power 3, where P and Q are two positive integers, and their LCM is given in this form, and HCF is given in this form, where A and B are prime number, then you need to calculate this. See, all we know is LCM always take highest power, right? So LCM will be what? A raised to the power 3 and the highest power of B raised to the power 4. So this will equate with this, which is given to us like it's A raised to the power and B S. So that gives us R as 3 and S as 4. Likewise, HCF takes lower powers. So HCF will be A square B3. I mean A square and B3, the lowest power. And the same way we can find the value of M and N, MS2 and NS3. So if we got our R and S, we got M and N, because see, this is we were given LCM and HCF in this form, in this and in this. So we got all these four values. Just simply put the value of M and R and S in this equation, and you'll get your answer as 35. So the correct answer is 35. Now let's do the fifth one. The value of C you need to calculate, for which these two equations will have infinite solution. Now by now all of you know, for any equation to have infinite solutions, you should have your A1 upon A2 must be equal to B1 upon B2, and that must be equal to C1 upon C2. And these are of course the coefficient of X, Y, and C1 is the constant, right? And this is for first equation, and 2 is for the second equation. So as you can see here, the constant are C is equal to C. So A1 upon B and B1 upon 2. So A1 is of course C, which we have to find, upon 6, which is the coefficient of X, 6. And then B1 is the coefficient of Y, minus 1. And coefficient of B2 is the coefficient of Y in the second equation. And then C is the constant in the first equation, and C2 is the constant in the second equation. So as you can see, of course, we do not know what the C is, but we know this is not equal to this. So that means this system cannot have infinite solution. So D cannot have any value that can satisfy this equation to have infinite solution. So the correct answer will be D. So which means it will have no value. It is true if it is for the other option, like for unique also it is not possible, infinite it cannot have. If the answer is like no roots, then it can have, we can always calculate C, but for this we cannot calculate C, so simply the answer will be no value. Now let's do the last one, which is very interesting. The number of polynomial having zeros this and this is, you need to calculate, then these 4 options are there, it will be 1, 2, 3 or more than 3. So see, as you know, the any polynomial, any equation can have infinite number of solutions, right? So polynomial with zeros, this is x plus 2, x minus 5. These are the factors, and I've written k over here because k is any non-zero constant, and these are the example. It can have x plus 2, x minus 5. You can put k as 1. You can put k as 2, 2x plus 2 and x minus 5, and you can put 3. The constant 1 to infinite, you can put any constant here. So these 3 are just the example. So of course, since the infinite is not given as an option, so you will choose more than 3. It could be, the option could also have been more than 4, more than 5, more than 6, or infinite solution. So this is the reason why the number of polynomial with these zeros, or with, in fact, for that matter, for any zeros, it will always be infinite. If that option is not given, then more than 3. So I hope you like this video and the explanation. So see the caption for more details and follow this page to have your daily maths lessons.